classical students. So today we are going to start with limits of trigonometric functions. It is important for this lecture for the students to know what is range of a function. Let's say the function is f of x. So first we'll define what is domain of a function f of x. Domain of a function is defined as set of all possible inputs for the function. And corresponding to the possible inputs, set of all outputs means the value of the function f of x. Of a function is known as its range. So range is related to domain. In order to understand better, let's say we have a function f of x is equal to x squared. So now possibly set of all real numbers x, set of all real numbers could possibly be the domain of this function, values of x. Corresponding to the values of x, the values of f of x would be the range of this function, right? But let's say we talk about a function f of x is equal to 1 by x. In this case, what can be the domain of the function? So the domain of the function, one domain of the function could be set of all possible real numbers, but except x is equal to, yes, can you guess, Ishma?
0.
Very right. So the corresponding values of f of x, what we will get would be the range of the function. Very right. So imagine if a function is f of x is equal to x squared, we might as well say that the domain is, let's say, 1, 2, 3, let's say. We can choose domain as per our needs and requirements. We need not take all possible outputs of the function. We can take a small set of all those possible values could be considered as domain of the function. So let's say for this function, x could be set of all real numbers, x could be set of all natural numbers, whole numbers, or integers. Here we are taking set of all natural numbers as domain. So corresponding to this, what will be the range of the function? Would be 1, 4, 9, right. So this is a little bit about range and domain of the function. Now guys, based upon this, we're going to start limits of trigonometric functions. Here we state one theorem. Let f and g be two real valued functions with some domain of definition, right? Such that f of x is less than or equal to g of x, right? For all x in the domain of the function. In the domain of the function, right? Then for some real number a, I'm going to state something. For some particular real number a, here the condition is that the limit of both this function should exist. Means limit x approaches a, I'm going to find the limit for a, f of x, as well as limit x approaches a, g of x, both exist. We know the meaning of this. That means negative limit, left hand side limit is equal to right hand side limit for both these functions. In that case, what? We're going to make an important statement. In that case, limit of the function f of x when x approaches a would be less than or equal to limit of function g of x as x approaches a. A very important result. Once again, what did I say? We are defining f and g as to be two real valued functions, right? With some domain of definition, you need not take all possible values for the variable x or y, whatever we define this function with. Rather, you can define some subset of those values. I'm going to say, let's say if it is f of x or f of y or g of y, then values of y. You need not take all the values, possible values. You can take some of those values and define that as domain of these two functions, same domain. So in such a way that f of x is less than or equal to g of x for all x in the domain of definition. Then for some real number a, if both limits exist, then we can definitely say limit of f of x, x approaches a, is less than or equal to limit of g of x as x approaches a. All right. So here it is demonstrated like this. See, this is the function y is equal to g of x. See, here when pointing towards f of x means less than, the value is less than that of g of x. So g of x, obviously the curve would come up, and the curve of what? The curve of f of x will come, down. So this is the value of x, which is equal to a. And for this, it's demonstrated geographically. Limit of f of x, x approaches a, would either be less than or equal to limit of g of x as x approaches a. Right? And now, students, we go for sandwich theorem. Sandwich theorem. Okay, the T is not there. So what is the sandwich theorem? Now, student, there's something else we want to define in terms of limit. So let's say this is our one function, and then this is the other function, and this is still other function. Okay, and you see at the point A, the limit is same. All right, They are all converging towards the same values. So this is my y is equal to, let's say, h of x. And this function is y is equal to f of x. And this function is y is equal to g of x in between these two. Okay. X. So how do I define sandwich theorem? If f, g, and h be real functions, real valued functions, such that you have observed from the graph that the values of f of x is less than or equal to g of x is less than or equal to h of x. See guys, if the curve had been like this, I wouldn't have included the equal to sign. But at this point, they are all having same value. And that is important for me. F of x is less than or equal to g of x is less than or equal to h of x for all x in the common domain. Means I am evaluating all these functions for some values of x, in some common domain. Means I'm taking some inputs of x. This is what is meaning of common domain. I'm taking some set of values for x, maybe till here, maybe till further, starting from 0, x is equal to 0, more values, right? For all x in the common domain of definition, how I'm defining this. Now, for some real number a, now whatever I'm going to state is based upon this, that the limits of all the three functions exist. Means limit x approaches a, f of x is there, and limit x approaches a, g of x exists, and limit x approaches a, h of x also exists. By existing, we have already seen what's the meaning of whether the limit exists. Means the left hand side limit is equal to right hand side limit. We can say limit x approaches a negative, some function f of x is equal to limit x approaches a positive f of x. This is the meaning of that the limit exists. Both the results from left side and right side are converging. They are pointing towards a fixed point, right? So then we say the limit is existing. Otherwise, limit is not existing. If it is like this, the limit is not existing. Okay. So this is done. Now, if this limit exists, and imagine students that f of limit x of a, f of L, let's say this is equal to L, this limit, and this limit of the uppermost function is equal to L. Now we can derive a judgment from this sandwich theorem. The function g of x is sandwiched between two functions h of x and f of x. It's like sandwich, you have a sandwich. So in between sandwich, you have something, So if some parameters of this and this sandwich is defined, so we say this also has the same parameter, something like this is the meaning of this. So if limit of f of x approaches a is equal to L, and this limit is also L, as is being pointed out by this point, then I would say that limit of g of x as x approaches a would also be equal to L. This is my sandwich theorem. Why this theorem is important? because of this theorem, students, I can derive these results and I will not be going for the derivation. You can refer to NCERT book. This is first derivation, which I'm not doing, because we somehow, leave it to you that you do it. You can do it. Refer to NCERT book, and using this sandwich theorem, if you somehow observe that you have functions, two, three functions, and this function is sandwiched between these two functions, and all the three functions, the limit exists, so we can say, if we know the limit of this and this is same, the limit of this function will also be same, right? Which have all the values either equal to particular point and or less than and greater than this function for all the possible values of x in the domain defined. Okay. Based upon these theorems, we can derive three results. What are the three results? The first result is, I'm not giving derivation. See, students, you might ask how it comes. I'm not, if I get time, I'll make another videos on this. So limit, I'm just going to define the results now. X approaches 0. Sine, it's really interesting how these results come. Sine x by x. So this is of the form of 0 by 0, and we know whenever the limit is of the form of 0 by 0, the limit is possible, right? If it is of the form of some positive number by 0, then limit is not possible. Sin x by x is equal to 1. Second limit, x approaches 0, tan x by x is equal to 1. The third one, limit x approaches 0, 1 by cos x divided by x is equal to 0. Based upon this, students, we can do a lot of sums, finding limits of trigonometric functions. So let's do first sum. Okay, guys. So he's asking us to find limit x approaches 0, theta by sine theta. Okay, remember, students, theta is in radians. Okay, so we have the limit. What agenda can you speak? Limit x approaches 0, sine x by x is equal to unity. So we want to bring this function to this. How can we do it? See, the trick is 3 by 4 is equal to 1 by 4 by 3. So tell me, how can we do? Limit x approaches 0. How can I bring it? Sine theta by theta. I just told, see, 3 by 4 is equal to 1 by 4 by 3. So it will be
1 by.
Yes, good. Limit x approaches 0, 1 by, beautiful, sine theta by theta. Beautiful. So that will be equal to, now we will write algebra of limits. Now this will be equal to limit of x approaches 0 of 1, right? That will be 1 divided by limit of x approaches 0, sine theta by theta, right? So this will be equal to 1 by 1 is equal to 1 is the answer, right? Second question. So now we have limit x approaches 0, sine 3x by 5x. So yes, students, think how can we do it? So just little bit of manipulations. We want to have this thing, sine x by x. We want to have this. So we'll have limit of what? Anyone can say? Obviously, we can't change this thing, limit 3x. But we can definitely go for 3. We can definitely say 5x is equal to 3x. Right? If we just write what? 5 here divided by, come on, 3. We can do like this. X approaches 0. 3 is cutting with 3. Ultimately, it is 5x, right? So then we got the answer. So it is, so So no, so 5 by 3 will come outside. 1 by 5 by 3 will become 3 by 5, right? Because it is 1 by 5 by 3, right? 3 by 5 into limit x approaches 0. What? Ishma, can you say? Sine 3x by 3x. So this will be equal to, come on, 3 by 5. All right. So this is also done. Are you able to understand? Third sum. So we can do now limit theta approaches 0. Instead of x, we are having theta. Okay. Sine a theta divided by sine b theta. So can we do it? So this is equal to limit theta approaches 0. So yes, think about this. So we can write like this. It is sine a theta by theta divided by limit of theta divided by, sorry, no, it is sine b theta divided by theta. Do you agree with this? Hello, Ishma.
Yes, sir.
Well, we can write, see here, sine a theta divided by sine b theta is equal to sine a theta by a, right? Whole divided by what? Tell me. Sine b theta by a. No, no, not b. A cancels with a. But we wanted to have theta, na? So we'll write instead of a theta here, theta. Right. So we got it. So this is equal to, yeah, students, how can we do it now? So this is equal to, but we want to have same thing here. This is a theta. So it should be a theta here, right? How can we have it? Yes, students, can you tell me simple? Multiply and divide this by, tell me, you want to have a. So if you write a here, you have to multiply also by a. A will go inside. So this will become a limit theta approaches 0 sine a theta divided by a theta divided by, similarly, yes, tell me students, it will be b comes outside limit theta approaches 0 sine b theta by b theta. See, a, b are constants. These are, so constants can go outside the limit. I hope you remember that limit x approaches some limit lambda of f of x. Let's say x approaches 0 would be equal to lambda can be taken outside. Lambda is constant, right? So this would be equal to, yes, students, come on, a divided by b. So this is equal to a by b. We got the answer. All right. So like that, students, you keep doing some manipulations and you can do a lot of sums here, okay? So now let's do this sum. We have limit x approaches pi by 2. So pi by 2 is how many degrees? 90 degrees, right? So 1 plus cos 2x divided by pi minus 2x square. So this is the sum. How do we do it? So just as practice, if you do practice, you will learn different techniques of doing different sums. So we can do this like, it's limit. Okay, so here we'll change the limit. Okay, so we'll put what? We'll put x is equal to pi by 2 plus h. Pi by 2 plus h. Now, student, when x approaches pi by 2, so h will approach. Yes, Ishma, can you tell? Harjinder, as x will approach pi by 2, x pi by 2, pi by 2, pi by 2 cancels, the h will approach. If you put instead of
X.
if you put equal to pi,
0.
pi by 2 will cancel. So h will approach, not x. Instead of x, you have already put pi by 2. Pi by 2 is equal to pi by 2 plus h.
0.
H is 0. So this is not the right way of telling you, students. We are not putting x is equal to pi by 2. We are making x approach pi by 2. So h will approach 0, right? H will approach 0. So now we can change this. So this would be equal to, one second, this would be equal to, yeah. So we'll write limit h approaches, x approaches pi by 2 means h approaches, yes, Ishma? H approaches
0.
plus cos 2 instead of x, I will write pi by 2 plus h, right? And divided by, here it will be 1 minus 2 into pi by 2 plus h whole square, right? Whole square, right? So how do we do it further? So this is equal to limit h approaches 0. Here, what do I get? Here I get 1 plus cos of pi plus 2h. I'm simply taking 2 inside, multiplying 2 with this, right? And divided by, so here what do I get? Pi minus 2h whole square. Very simple. Okay. So this is equal to what? Limit h approaches 0. So I can write 1 minus cos of pi plus 2 at pi, the sign doesn't change. But I'm sorry, the trigonometric ratio doesn't change, but the sign changes. So it will be 1 minus cos 2h divided by, so what do I get here? So this is equal to, now you see that, what is pi minus 2h squared? So this is equal to, what is this? This cancels out, minus 2h squared is 4h squared. Is it right, Ishma? So
Yes, sir.
now you need to know the formula for cos 2h. Cos 2h is equal to, do you remember? Is equal to 1 minus 2 sine square h. Easily you can derive this. You know, you can derive this easily. Cos 2h is 1 minus 2 sine square h. Okay. So now we can write it like this. This is limit h approaches 0. So what do I get? So I get, see, 1 minus cos 2h is 1 minus 2 sine square h. So this becomes what? 2 sine square h. One step I'm missing. Okay. Divided by 4h square. Right. So now this is equal to, come on, students. So 2 1s are 2, 2 2s are 4, 1 by 2 coming outside. So we are having, come on, we are having, now you can do it, limit h approaches 0, it's sine square h. Can you help doing this? So sine square h is basically, sine square h is what? I can write sin h into sin h, sin h into sin h divided by h into h. So my job is done. So this is equal to what? 1 by 2 into first it will be limit of this into limit of this limit h approaches 0 this because we have you remember limit x approaches a f of x into g of x is equal to limit x approaches a f of x into limit x approaches a g of x. So this will be 1 by 2 into 1 into 1. This is equal to 1 by 2. Am I right? Very good. We have 3 more minutes. Let's do one more sum and then I give you few sums. Okay, remember students, here one thing is there. There are some trigonometric formulae. So it would be better if you remember all those trigonometric formulae. Just brush up your skills and then it will be helpful. But they will not give you something very difficult trigonometric formulae, but you should just memorize them. What are the different trigonometric formulae? So like here we are going to use another trigonometric formula. So we can do the sums. Okay. So one sum I'm taking from exemplar, right? So he says write down limit x approaches pi by 6. Okay. So 2 sine square x plus sine x minus 1 divided by 2 sine square x minus 3 sine x plus 1 by using factorization method. He has particularly mentioned that use factorization method. Okay. So how do I do it? Okay. You will see that. Now this limit, I can say this limit would be equal to this limit would be equal to right here limit x approaches pi by 6, right? So yeah, can anyone tell me how can I factorize this? 2 sine square x plus sine x minus 1. So you apply little brain. So you see that 2 sine x minus 1 into sine x plus 1. Right? And here also in the bottom you're getting 2 sine x minus 1. Maybe one step is missing. You find out that step. It is sine x minus 1. All right. So it's very simple now. It is limit x approaches pi by 6. So this is cancelled. So this is sine x plus 1 divided by sine x minus 1. Very, very simple. So this is equal to sine pi by 6 plus 1 divided by sine pi by 6 minus 1. Remember, the limit of a polynomial function can be found out as the value of the function at the prescribed point. So now sine pi by 6, you should be knowing it. Anybody knows the value of sine pi by 6? Sine pi by 6 is 180 by 6. That is equal to 30 degrees. So sine pi by 6, sine 30 is how much?
1 by 2.
So this becomes 1 plus 1 by 2 is 3 by 2. And here it is 1 by 2 minus 1 is 1 by 2. So the answer is, so this is pi by 6 minus 1, right? So it will be 1 by 2 minus 1. I'm sorry, I did a mistake. It should be minus here. So it will be -3. Okay, students. So now I want to give you some homework also. Yes, students. So these are some sums I want you to practice and write down the answers in the comment section. This is first sum and